Hey guys, this is Srini and you're watching Python tutorial videos on my YouTube channel, Python for Microscopists. In the last couple of lectures, we talked about grain size analysis, cell analysis, where we successfully separated individual cells or grains, using watershed and also traditional segmentation. And the result, we dumped it into a CSV file. Now, let me take a couple of videos, to explain how to deal with these CSV files from within Python. Of course, you can deal with them in Excel, and just like why we are doing Python and not using prepackaged software, the same reasons apply for why we should be working with data in Python and not in Excel. Of course, Excel is great. Obviously, I use it every day, but with Python, again, it makes it a lot easier to handle large data sets if in future you end up doing that. And also to manipulate data the way you want, to generate the plots that actually reflect the true nature of the data and the message that you're trying to convey. So let's take baby steps. In fact, let's jump in and let me introduce you to a library called Pandas, Pandas. This is the library within Python, just like scikit image that we have used before, just like OpenCV. This is another a library that we would be importing. And Pandas, it's a Python library that enables data analysis, obviously. And think of it as an extension of NumPy, where it makes data handling of arrays especially almost as easy as handling them in Excel. So in this tutorial, let's look at the loading, viewing, understanding data. Basically, just get a quick introduction to Pandas. So once you get the CSV file, for example, if you already have a CSV file from, let's say, our grain size analysis, to generate a plot, it's extremely straightforward and easy. In fact, let's go ahead and jump in, and I've written like 3 lines of code here just so I can quickly show you how to do this quick plot. So in this case, we are importing Pandas as PD. This is again a good convention. And I'm defining what we call a data frame. We'll look into that again a bit more detail later on, but just a variable called df equals to pd.read.csv. It's just one line to read the CSV file. And my CSV file is located right in this path, in this directory. So that's the path of my CSV file. And then now all I'm doing is using the plotting function that exists within Pandas. You can always use matplotlib or something else, but in this case, of course, it's powered by matplotlib in the background anyway. So I'm gonna look at the area column, okay, and then plot a histogram, and I want to label that that plot. The title would be area here, and of course it's a histogram, so I want 50 bins. So that's pretty much it. When I go ahead and run this, there you go. The title is area. I hope you can see this. The title is area, and I have 50 bins right there, and that's pretty much it. So this is as simple if you already have a CSV file, right? So let's go back and I'm thinking instead of importing a CSV file, let me just quickly show you how the data looks like, once it goes in. It treats CSV file as nothing but some sort of a NumPy array, right, when it imports it. So if we define a matrix, let's say, again, I'm a bit more prepared for this tutorial. So let me go ahead and copy and paste so I don't waste my time or your time, watching the screen. When I type. So anyway, so here I'm importing Pandas as PD, and my data, it's just a 3x4 matrix. I have, like, if you want to think in terms of columns and rows, I have like 3 of these and 4 rows right there. So I defined this, and now let's define our data frame. Yeah. So df equals to pd dot data frame. Okay. You'll see what data frame looks like. Just data. Okay, so if I go ahead and print this, let's say I want to print this data frame, how does that look like? So there you go. So the data frame, actually, you see this column names like 0, 1, and 2, and the row names 0, 1, 2, 3. This is index, okay? These are indices, 0, 1, 2, 3. And this is, it's actually assigning some default column names. And we can actually define the column names and index if you want. So for example, I want to just say, well, let's do index later. Let's just do my columns, if I can type it correctly, equals to, and let's call the first one area, okay? And the second column, let's call it intensity. I'm just giving some random names for now. And the next one, let's call it orientation, I-E-N. I'm just using the names from our grain size analysis. Okay, so now when I run this, so each column has a title now, okay? And I can invoke all of these numbers from within a column just by calling area. We'll see that again later on, okay? And same thing, you can change in the index, you can assign one of these columns as your index column. So if you want to assign, by default, the index goes from 0, 0, 1, 2, 3, and so on. But if I don't want that, if I want to force it to go from 1, I can define my own index. So it's just index equals to 1, 2, 3, 4, right? So 1, 2, 3, 4. Yeah. So now if I run this, you should see that, let me go ahead and scroll this up. So my index starts from 1, 2, 3, 4, and then this is the area and so on. So the lesson here is a data frame, like any data can go into like Pandas. Well, of course, primarily most people use CSV, but you can actually provide it as an array. And then once it's in an array, it actually structures it in a very easy to understand format. Yeah, you can see that this is almost Excel-like. Yeah, I have a column and I have different rows here, which makes data handling very easy within Pandas. So what do we do next? Let's look at a CSV file. I have this. It's a bit interesting CSV. Let me zoom in. So what we have here is I believe 4 sets of data. So I have set 1 with 25 images, set 2 with 25 images, set 3 25 images, set 4 25 images. So total 100 images. I have set 1, 2, 3, 4. Each image is an image of is it grains, or it's a cell image. It's an image containing a whole bunch of cells, and one person at least analyzed each of these images and then written down how many cells he or she, well in this case a he, identified in that specific image. And we tried the second person to kind of do the same exercise. He kind of gave up after doing the first 3 images because it's literally ridiculous to do things manually. But I've used the watershed-based cell detection algorithm to actually analyze these images, and I actually analyzed it under 3 different settings. Yeah, I changed one of the settings and then how it affected the detected cells, the total number of detected cells. And these are like auto threshold 2, 3, and 4. Okay, so we have one manual and a few of these auto. Auto is easy, so I just changed the parameter and then did this. And the manual took quite a few days. So and also this person overlooked some of these images. Again, that's a problem with manual. You probably you think that, okay, I've already done this, but there are a few missing data, which is also okay. Yeah. So this is the data set. So let's understand the data set. This is a CSV file and I captured this. And obviously you may have like different types of data that you want to analyze, but this is anyway an example I would like to use for this tutorial. Okay, so now that we understand this, let me delete everything. Let me clear the variables. Let me clear the screen and start from scratch. So we have, so let's start by importing this. Yeah. So my data frame is equal to, again, data frame is the structure that it's actually putting this data into. My data frame equals to pd.read_CSV right there. You can read Excel file, but in this case, this is a CSV file, read_CSV, and it's called manual. There's a whole bunch that you can do here. Go ahead and experiment with that. It's called manual versus auto.csv. Okay, There you go. And let me go ahead and run it. Okay, so looks like I'm in the right folder and everything. So that's how you just read CSV file. Now you can, once it's in the data frame mode, now you can do a few things. Like for example, let me look at my notes in terms of what I should be showing. An overview of the data frame, right? So if you want to get an overview of data frame, you can just do, let me just print df dot, just type info. I think that should do info. Okay. So now if you print this, it's going to print an overview of your data set. It's going to say, okay, you have like 7 total columns. Of those, the first column is called unnamed 0. Well, we didn't assign a label to the first column apparently. So if I go back and look at this, there is no label, there is no title for my set 1, set 2, set 3, okay? But the others, I got a title. So image has 100 entries, unnamed has 100 entries, manual has 94 entries, 94 non-null entries. What does that mean? Well, if I go to manual, this is null, right? Another one, this is null. So I do not have 100, even though I expect to see 100. Manual 2 has only 3 and all others has 100, and what types of data and all types of information. So info gives a very quick snapshot of your CSV file. Now you can look at what the shape of your, just like we have been doing with our images, trying to understand the shape. So dot shape actually gives that this is 100 by 7. So we have 100 rows and 7 columns. That's what dot shape does. Now you can print the entire DF on screen. So let's just do the data frame, printing of data frame. So it goes all the way, you can see from 0, and it kind of truncates somewhere, and then it shows the bottom data. And as you can see, wherever we do not have any data, it actually fills it with NaN, not a number, which makes it in fact a bit easier for us to handle these empty cells later on, because we can fill them with some some number, we can delete that row, or we can decide on what to do once we know that we have some not in number rows or columns. Okay, so that's the entire data frame. Now instead of the entire data frame, we can actually do look at only the head, like df dot head. This actually prints, let's see what it prints. It prints the top 5 by default, the top 5 rows, and you can have a look at the data. But if you want to look at the top, I don't know, 7 rows, for example, just put 7 in there, and then you can see the top 7 rows. Just like head, we also have tail. So if you want to look at the bottom, here is the bottom 7. And again, just like head, if you don't type any number in there, you just look at the bottom 5 rows by default. And of course, the titles, the headings are always there. What else? And the first line here is always considered to be the header. You don't have to specifically specify, I want to call the header. It's there. It's always there. You don't need to specify it. It always prints. And like I mentioned before, the first column here is by default the index, and you can make anything else the index. You can make your image name to be the index if you want. So what else do we do? Let's actually assign another column to be index, okay? Because I just mentioned. So instead of printing this, let's we have our manual. Let's use the same file, and instead of df equals to df dot set index, let's actually use the image column. Okay, so all we need to do is just give it a name, and that becomes the header. In fact, let's assign it to a different data frame. And by doing this, df is not altered. So if I just go ahead and okay, it's there. We still need to print. Let's say df dot head. Okay, and let's do this first. So df, it's still the index is 0, 1, 2, 3, 4. Okay, Now if I do df1, you should see that the index is image, image1, image2, image, and so on. Okay, so you can put anything as your I mean anything that makes sense, right? Typically the index needs to be unique, so if you have a unique identifier for your row, then that would be the best index. Otherwise just leave it as default. So what else do we have? I'm just going through my notes of there are a lot of things that we can actually do here. I just want to make sure you at least we talk about the top 10 useful things. So after this, let's say we want to print, go ahead and print columns. Okay. So as you can imagine, that just prints out the column names as an array. Okay. So unnamed, manual, manual2, and so on. So this is how you can actually look at the column names, and like I already mentioned, you have the not in numbers. We'll talk about how to deal with not in numbers in our next lecture, where we talk about manipulating data. In this tutorial, let's just focus on understanding the data and not manipulating much. Now, if you want to look at all unique entries in your rows, we have the set1, set2, set3. Let us actually print df and which one is our set? Unnamed, right? So unnamed, am I typing it correctly? We should change the name of this unnamed, but let's keep that for now. Unnamed 0, and yeah, we have unnamed 0. And if you actually type dot unique, it actually types all the unique entries. So if I run this, we should see set1, set2, set3, and set4. So again, understanding the data here, set1, okay, we have multiple set1s. Well, we have 25 of those, and then it goes to set2, set3, set4. So this is one way of looking at, again, what are all the unique entries within a given column here. You can look at multiple columns, of course. I'm actually getting a bit irritated by unnamed 0, so let's go ahead and rename this. The way to rename this is just df.rename. So let's not print. So let's just do df.rename. In fact, let's df1 equals to, let's ignore this. Okay. So let's create a new data frame, and I'm going to call df1, the new data frame is equals to the old data frame, where we rename something. Okay, so what do we rename? We rename multiple columns. If you want, you can do multiple columns, but just let's just rename. Again, this is let's say unnamed, where is it? Unnamed colon 0. Okay, let's say, and what do we want to rename this to? Okay, this is, I want to rename this to image underscore, let's just say set. Image underscore set. I think this should do it. Let's go ahead and print df1.columns to see if it actually renamed it. Okay, so there you go. So index is image, our column titles are image set, image, manual, and in fact, if you just print or df.columns, you can actually see what the old ones are. So the old one was unnamed 0 and blah blah blah. The new one is image set. So it actually changed this. So what else can we do? If you want to only look at one column, actually, so let's actually go back and ignore these two. If you just want to look at one column, let's just say the column name is manual. You just need to do print and df and manual. That's pretty much it. So if you click on that, so this is just one column. You can assign this to a new data frame, right? So you can actually say, okay, my new data frame is df1 is equal to that, and then you can just print df1. Then you can clearly see that our new data frame is a data frame that has only one column. So this is like extracting your, in a way like extracting information. Again, I'll cover this in our next tutorial, but again, if you want to take like slice your columns or your rows and then assign it to a different data frame, you can always do that. And the data types itself, again, I'm not sure if you realized it from our initial info. Our data frame itself, let's go ahead and print this. Actually, if you type df.data types, it actually identifies all the data types automatically. Unnamed 0 is an object. It's an object. Manual is float 64, int 64. If you look at our data set, this is a name, right? I mean, image is a name, set is a name, but here you have numbers, dot 0. Here it started off with some numbers, and then you have like all these integers. So it automatically detected them. If it is a name, if it's text, by default it's calling it object, and then we have the float, a couple of float columns, and then we have int columns. So the data types are automatically identified. And let me just finish this this tutorial by just typing, if you want to, again, a good description of each of your column. So it's just describe. I use this quite a bit actually. If it describes, kind of gives you a snapshot of what is going on with each column. For example, let's just look at the column called manual. Okay, so the column manual, there are total 94 entries. Of those, the mean value is 100, the standard deviation is that, and minimum is this, and 25th percentile, 50th percentile, 75th, excuse me, and the maximum is 120. This gives an excellent, a great overview, especially if you're looking at data from images. You can look at what the minimum pixel value is, maximum, what the standard deviation is, and all of that, or objects, that you have segmented. It doesn't matter. So this kind of describe gives a great overview of your data set that you're actually dealing with. And this is, as you can see, so much easier than doing all of these in Excel. Excel can do a lot of course, everything I showed you, Excel can do, and it's got an easy interface. But then to do some sort of a math, all of this, if you master Pandas, then you will never go to Excel once you master Pandas, because there's so much you can do. So let me stop this tutorial right now, and then in the next one, let's actually look at how to manipulate this data. Now we looked at how to interpret, how to understand, how to handle the data, but let's look at a few manipulation tools. Thank you very much. Please subscribe to my channel if you like these videos, and do not forget to like them if you like the content of the video. And if you have a feedback, please leave that in comments, and I assume you be nice, okay, when you leave a comment. Thank you very much, and let's meet in the next tutorial.